Okay, so this is going to be the solution for question 3B of PSPM 2223 SP025. Okay, so let's look at the question. A dry cell of EMF 1.5 volts. So let's just highlight that. So that's the EMF is connected in series with a 1 ohm resistor. Determine the cell's internal resistance if the voltage across the terminals is 1.4 volts. Okay, so it's actually useful to just draw a diagram fairly quickly. I will have a resistor, so that's going to be 1 ohm, right? And then I'll have a battery. Now in this particular case, because they mentioned internal resistance, I will have to add just a little small resistor, right? And then add it to my battery. Okay, and it looks like that. Now just to differentiate between my internal resistance and the resistor, right, I'm just going to label it that this particular section, this red square on your screen right now, is actually in the battery, and that the terminal of the battery is actually outside of this circuit, outside of this red box. Okay, so the dry cell has an EMF, right? So EMF of 1.5 volts. The resistor, I'll just put it there as R. The resistor has a resistance of 1 ohm. Now I'm looking for R. Now if I have 1.5 volts, right? Sorry, that's not right. Okay, if I have an EMF of 1.5 volts, some of the voltage is going to go to the resistor, and some of that voltage is going to go to the internal resistance. Okay, so the voltage across the terminals is 1.4 volts. What that means is that IR is actually 1.4. Okay, now what about I and small r? Well, small r is what we're looking for, and EMF is 1.5. Now the problem is that I do not know what is the current going through it. So here I can apply Ohm's law. So this is going to be voltage across the resistor, right? Which is equals to 1.4, and that is equal to IR. My R here is actually 1 ohm. 1 ohm. So my I is actually 1.4 amps. I'm going to take that value and substitute it in here. So what I'll have now is actually 1.5 equals to 1.4 plus 1.4 times R. Okay, so if I rearrange that, I'll have 1.5 minus 1.4 over 1.4, and that is going to give me R, right? So let's just quickly do that. What we'll have is actually 7.143 times 10 power of negative 2 ohms. And that is my final answer for the internal resistance. Thank you very much.